Hi friends, welcome to the Unit 6 Day 7 Notes. You notice that these notes are already completed and the video that you watched is without sound. So I'm just going to highlight what we talked about in that video and really discuss, now with sound, what's happening. So starting off, the big thing with applying in the sine and cosine ratios, we've already talked about tangent. So sine and cosine just add on to that. But really now that we're combining all three, it's helpful to remember when you use each. Tangent is abbreviated tan, so if you see that, just know that it's tangent. And the tangent of A is the length of the opposite side divided by the length of the adjacent side. That's review. Sine, which is abbreviated SIN, so a common mistake a lot of students make is that they say this is sin, it's really sine, and that's opposite, the length of the opposite side over the length of the hypotenuse. And then cosine, again, cosine, not cos, but cosine, is adjacent over hypotenuse. Unless we tell you otherwise, make sure you round the values of trigonometric ratios to 4 decimal places, so you're doing it to the 4th decimal place, and round lengths to 1 decimal place. So down here, we have a way that you can really remember the different parts of sine, cosine, and tangent using this saying called so, ka, toa. And so stands for sine, which is opposite over hypotenuse. And you can see that it kind of sets itself up. So if you make it, it is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And that's ka, so adjacent over hypotenuse. And then toa, which is opposite over adjacent, which you already know. And then over here, we drew the reference. The reference angle was marked. And so I just put in opposite hypotenuse, adjacent hypotenuse, and opposite and adjacent. If you notice the pattern here is that each thing appears twice. So you have hypotenuse appears twice, opposite side appears twice, and adjacent appears twice with all of these. So each of them is missing one of the sides when you evaluate with it. Here in example A, what we're doing is we're finding the values of sine for R, and then also for sine of angle S. So the values for these we're writing as a fraction and as a decimal. So when you do that, what you want to do is circle the value first. So I circled sine of R, and then I found opposite over hypotenuse. And that's how I got the 15 over 25. Whenever you have a chance to reduce, please reduce. And then in my calculator, I did 15 divided by 25 to get the 0.6. And that's how you get the decimal. Your calculator will actually figure that for you. Same thing with sine of S. So we did 20 over 25, and then we did reduce that down 4 over 5, and then just did that in my calculator to get the 0.8. When you have to round, make sure that you round to 4 decimal places. So when I did number 2 here, we got a decimal that went on forever. That's called an irrational number. It's because we divided by this 13 here, 12 divided by 13. So with that, when you have a situation like this, where your decimal goes on forever, what's going to happen is non-terminating decimal. So when we have that, we had to round, so we rounded to 4 decimal places, and we had to do that for both of these. Same thing also with number 3. You've watched the first video, hopefully, or you've seen me go through, how I'm writing each of these, but you're just setting it up. With sine, you're always doing the opposite over the hypotenuse. Notice that it matters which angle you pick. So if I picked S, opposite of S, the opposite side is 10, and the hypotenuse will always be the same. So whenever we're talking about opposite and adjacent, you have to be really careful to make sure you get the right location. Hypotenuse is always going to be the same no matter what. Cosine is adjacent over hypotenuse. Similar idea, so I circled A when I did this first, and then I did the adjacent side length, which is 48 over 52. Reduce that down as much as possible, so 12 over 13. And then 12 over 13 we actually did up here. And so I just re-recorded my decimal approximation. Cosine of B, so I circled B, adjacent's 20, then 52, reduced that down, and then got the decimal approximation. Very similar with the rest of these as well. And then for this last part, example C, it says use sine or cosine. You actually want to use any ratio. So at this point in the course, what you want to do is think about which one is going to be the best one to use. So here, the way this is set up, I only have this 57 degrees as an angle that I can use. I can find the missing angle measurement here and use sine and cosine again. But what instead I did was just I'd use the 57 the whole time, and then I also took advantage of tangent. So with sine, the reason I picked sine for B is because sine is opposite, which is the 14, over the hypotenuse, which is B. So I had sine of 57 degrees equals 14. And that's how I started with this problem. Then what I did is I wanted to get b on both sides. So I multiplied by b. That gets rid of dividing by b. We don't want any variables in the denominator. Then I had b times sine of 57 degrees equals 14. Divide by sine of 57 degrees on both sides. And I get b equals 14 divided by sine of 57 degrees. When you put this in your calculator, make sure you use parentheses and make sure you close the parentheses. So when you put sine of 57, you'll get an open parentheses. Make sure you close it after you do 57. Also make sure your calculator is in degrees. It'll say DEG at the top. So that gives me my value for b. Similarly to find tangent, so we circled the 57 degrees and then we multiplied then we set tangent of 57 degrees is equal to opposite over adjacent, so 14 over a. Then we multiplied by both sides by a, again because a is in the denominator, and then we divided by tangent of 57 degrees, and then we got a is approximately 9.1. If you notice on this side we're finding the side lengths, that's why we that's why I approximated to 1 decimal point. And then for the other pages earlier, we're doing 4 decimal places. So be careful if you're finding the values of the ratios or if you're actually finding the side length. So in this case, we're finding the side length. Similarly with 8, 9, and 10. So if you haven't, go ahead and try those, check them, make sure that the work flows with what I have as well. If you have any questions, please reach out to your instructor or myself. I'm happy to help. Have a great day.